Divergence. Next topic. The divergence of a differentiable vector point function f bar is denoted by div f bar and is defined as div f bar is equal to del dot f bar. Div f bar is equal to del dot f bar. Suppose if f bar is equal to f1 I bar plus f2 j bar plus f3 k bar, then div f bar is equal to del dot f bar. So del is a differential operator, I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, dot product with f1 I bar plus f2 j bar plus f3 k bar. So on making dot product, it is dou f1 by dou x plus dou f2 by dou y, k bar dot k bar, it is also 1, dou f3 by dou z, and which is a scalar function. The divergence of f bar is always a scalar function. The physical interpretation of divergence is, suppose if v bar is the velocity vector of the fluid, physical interpretation of divergence. And v bar is the velocity vector of a fluid, then divergence of v bar gives the rate of outflow per unit volume at the point of the fluid. At the point of the fluid. That is the physical interpretation of divergence. The another definition, solenoidal vector. Let f bar be any vector. Suppose if divergence of f bar is equal to 0, then f bar is said to be a solenoidal vector. Div f bar is 0, then the vector f bar is said to be a solenoidal vector. Definition, then physical interpretation, that is the rate of outflow per unit volume at the point of the fluid. If div f bar is equal to 0, then f bar is said to be solenoidal vector. Next, the next topic is curl. Curl of a vector point function. Similarly, let f bar be any differentiable vector point function, then curl f bar is denoted by curl, curl f bar, and it is defined as curl f bar is equal to del cross f bar. Del is the differential operator, cross product with the vector f bar. Suppose if f bar is equal to f1 I bar plus f2 j bar plus f3 k bar, then curl f bar is equal to del cross f bar is equal to determinant of the first row I bar, j bar, k bar, second row dou by dou x, dou by dou y, dou by dou z, del I bar coefficient, j bar coefficient, k bar coefficient, and last row f bar, I bar coefficient f1, j bar coefficient f2, k bar coefficient f3. So on expanding this determinant, I bar into dou f3, I bar into dou f3 by dou y minus dou f2 by dou z minus j bar into dou f3 by dou x minus dou f1 by dou z plus k bar into dou f2 by dou x minus dou f1 by dou y. So this is the expansion of the determinant, and you can observe that it is clearly a vector function. It is a vector function. So we know that divergence of f bar is scalar function. Similarly, the curl f bar is always a vector function. Now the next definition is physical interpretation. Next, physical interpretation of curl. So how we observe in physical terms, physical interpretation of curl. Suppose, let us assume that a rigid body rotating about a fixed axis, and let us assume that v bar is the velocity of the point px comma y comma z on the body, and omega bar with the angular velocity, then omega bar is equal to half into curl v bar. This is the physical interpretation. The relation between omega bar angular velocity and the velocity of the point on the rigid body can be related by using the curl W. Omega bar is equal to half into curl v bar. Next definition, irrotational vector. Irrotational vector. A vector f bar is said to be irrotational if curl f bar is equal to 0 bar. We know that curl f bar is always a vector, so we have to assign 0 as 0 bar. 0 bar. Curl f bar is equal to 0 bar, then f bar is said to be an irrotational vector. So in this case, you can find a scalar potential phi such that f bar is equal to grad phi. So if curl f bar is equal to 0, then you can find a scalar potential phi such that f bar is equal to grad phi. And f bar is equal to grad phi. Immediately there exists a scalar potential phi such that f bar is equal to grad phi. Right. So this is the basic information about divergence and curl of a vector point functions. Problems. First problem, find divergence of f bar at the point 1, minus 1, 1, where f bar is given as xy square I bar plus 2x square yz j bar minus 3yz square k bar. So I have to find f bar. Given solution, given f bar is equal to xy square I bar plus 2x square yz j bar minus 3yz square k bar. Then div f bar. Div f bar means del dot f bar. So del is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with the function xy square I bar plus 2x square yz j bar minus 3yz square into k bar. So making dot product I bar 1. So dou by dou x of xy square plus j bar 1 dou by dou y of 2x square yz minus dou by dou z of 3yz square. So now these are the partial derivatives. When we are doing partial derivative with respect to x, y treat as constant, similarly z also treat as constant. So with respect to x means x become 1, the value y square plus dou by dou y of the entire term, y will become 1, 2x square z treat as constants, so 2x square z minus last term. With respect to z means 3y constant, 3y into 2z, that means 6yz. This is z square derivative 2z into 3y, 2, 3, 6 into y into z. This is the div f bar. Now our requirement is div f bar at the point 1 comma minus 1 comma 1. So substituting the point y minus 1, so minus 1 whole square plus 1, 2 into 1 into 1 minus 6 into y minus 1 z1 is equal to 1 plus 2 plus 6. The value is equal to 9. The next problem, second problem. Show that the vector is a solenoidal vector. We know that a vector f bar is solenoidal vector if div f bar is equal to 0. Solution. Let f bar is equal to 3y power 4 z square I bar plus z cube x square z bar minus 3x square y square into k bar. Now consider div f bar, that is del dot f bar, that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with the vector 3y power 4 z square I bar plus z cube x square z bar minus 3x square y square k bar. So I am making dot product dou by dou x of 3y power 4 z square plus dou by dou y of z cube x square minus k bar dot k bar 1 dou by dou z of 3x square y square. So the partial derivative 0 because these are y term, z term 3. There is no x term, all are constant terms. With respect to x derivative 0. This is also with respect to y, these terms are x and z terms 0. Last term also 0, so this is 0. So div f bar 0 means therefore f bar is a solenoidal vector. F bar is a solenoidal vector. Next, third problem. If f bar is equal to x plus 3y into I bar plus y minus 2z into z bar plus x plus pz into k bar is solenoidal, find p. So if the given vector is a solenoidal vector, find the value of p. So we know that if f bar is solenoidal, then div f bar is equal to 0, so that you can find the value of p. Solution. So write the given vector, given f bar is x plus 3y into I bar plus y minus 2z into j bar plus x plus pz into k bar. Since f bar is solenoidal, div f bar is equal to 0. That is, del dot f bar is equal to 0. Del means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with x plus 3y into I bar plus y minus 2z into z bar plus x plus pz into k bar is equal to 0. So making dot product dou by dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x plus pz is equal to 0. So which gives the first term derivative 1 అయిపోతుంది. Here this is also 1. The last term this will be p x0 with respect to z. So it is 0 p into z1. So 2 plus p0 implies p is equal to minus 2, which is the value of p. Problem number 4. Prove that div r power n into r bar is equal to n plus 3 into r power n. Hence show that r bar by r cube is solenoidal vector. Solution. So already we know that r bar is a position vector of the point x, y, z. It can be taken as xi bar plus yj bar plus zk bar. And r is magnitude of R bar. We have R bar is equal to xi bar plus yj bar plus zk bar, and R is equal to magnitude of R bar square root of x square plus y square plus z square. Then dou R by dou x is equal to x by R, dou R by dou y by R, and dou R by dou z is equal to z by R. Now consider divergence of R power n into R bar. Div R power n into R bar. This is del dot R power n R bar. So we know that del is a differential operator. I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot product with R power n into R bar. I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot product with R power n into R bar means xi bar plus yj bar plus zk bar. So now I am making the dot product. Dou by dou x of x into R power n. Similarly, dou by plus dou by dou y into dou by dou y of y into R power n plus dou by dou z of z into R power n. So making partial differentiation. So x1 into R power n treating as constant term plus x into uv form. X and differentiate just the one, R power n treat as constant term plus x constant term not treat just R power n means n into R power n minus 1 into dou R by dou x. That is the first term partial derivative. Similarly, second term partial derivative, dou by dou y of y 1 R power n treat as a constant term plus y into R power n की derivative n into R power n minus 1 into dou R by dou y. That is the second term partial derivative. Similarly, the third term z derivative 1 R power n treat as constant term plus z into n into R power n minus 1 into, with respect to z means dou R by dou z. But what we know that dou R by dou x is x by R, dou R by dou y by R, dou R by dou z is z by R, and R power n, R power n, R power n. So you can write it as 3R power n plus x into n into R power n minus 1 into dou R by dou x means x by R. Next y into n into R power n minus 1. Dou R by dou y means y by R. The last term z into n into R power n minus 1. Dou R by dou z, that is z by R. Right? So this is 3 into R power n plus here the common term n into R power n minus 2. n R power n minus 1. The numerator is R power minus 1. So n into R power n minus 2 I am taking outside. X into x, x square. Y into y, y square. Plus z into z, z square. So this is equal to, but what is x square plus y square plus z square? This is R square. So 3 into R power n plus n into R power n minus 2 into the entire term is equal to R square. Or I can write it as 3R power n plus n into R power n, or n plus 3 into R power n. This is divergence of r power n into r bar. That is the first proof. To show that the vector r bar by r cube is a solenoidal vector. Suppose if div r power n into r bar is a solenoidal vector. The solenoidal vector means this value should be 0. R power n into r bar is a solenoidal vector. If r power n into r bar is solenoidal vector, and what we have by definition, divergence of r power n into r bar is equal to 0. That means if n, this is solenoidal, then n plus 3 into r power n is equal to 0. So r power n never be 0, only n plus 3 value 0, that is n is equal to minus 3. When n is equal to minus 3, this value r power n means r power minus 3 into, therefore r power minus 3 into r bar is solenoidal. That implies r bar by r cube is solenoidal vector. That is our solution. R bar by r cube is a solenoidal vector. Next, problem number 5. Prove that div r bar by r is equal to 2 by r. First we write the information. We have r bar is xi bar plus yj bar plus zk bar, and r is magnitude of r bar, root of x square plus y square plus z square, then dou r by dou x, x by r, dou r by dou y, y by r, dou r by dou z, z by r. Already we have seen this in the previous problems, gradient problems. So we write like this, as it is we are writing the results, dou r by dou x, x by r, dou r by dou y, y by r, dou r by dou z, z by r. Now to consider div r bar by r. That means what? Del dot r bar by r. So that is del dot I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with xi bar plus yj bar plus zk bar by r. R bar means the numerator. So now on using the dot product I bar dot I bar 1, the first term is dou by dou x of x by r plus j bar dot j bar 1, it is dou by dou y of y by r plus k bar dot k bar 1, you get dou by dou z of z by r. So this is equal to, I can write this is summation dou by dou x of x by r. This can be written as u by v form. So you have to derive, differentiate with respect to x partially by u by v form. So this is summation. So u by v form means denominator r square, u by v form v square r into dou by dou x of x, that will be 1 minus x into dou r by dou x. Write all of it. Summation x by r, u by v form, v square v into dou by dou x of x, 1 minus x into r ki derivative with respect to x into dou r by dou x. That is summation r minus x into dou r by dou x, that is x by r square. This is equal to summation r square minus x square by r cube. Numerator LCM r square minus x square by r. Denominator already r square, so the value will be r cube. So this is for one term. So on expanding the summation, you will get 3 terms. First term r square minus x square by r cube plus Similarly for y term, r square minus y square by r cube plus for z term, r square minus z square by r cube. So 1 by r cube is common term, 1 by r cube. So here r square plus r square plus r square, that is 3r square. So I am taking out minus symbol, x square plus y square plus z square. Clear all of you. Denominator r cube, r square plus r square plus r square, 3r square, minus on taking outside x square, next term y square, next term z square. But what we have, x square plus y square plus z square is r square. X square plus y square plus z square is r square. So this is 1 by r cube into 3r square minus r square. It is 1 by r cube into 2r square. R square cancel. The required answer is 2 by r. The required result is 2 by r. Next, problem number 6. If f bar is equal to grad x cube plus y cube plus z cube minus 3xyz, then find the divergence of f bar and curly f bar. We have to find the two values, div f bar and curly f bar. First write the given function. Given f bar is grad x cube plus y cube plus z cube minus 3xyz. It is grad x cube plus y cube plus z cube minus 3xyz. It is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function x cube plus y cube plus z cube minus 3xyz. This is equal to I bar into dou by dou x of the entire term. X cube 3x square, y cube term 0, and differentiating partially with respect to x, z cube term 0, minus 3yz, x1 అయిపోతుంది, plus j bar into dou by dou y of entire term. X cube term 0, y cube 3y square, z cube term 0, minus 3xz plus k bar into dou by dou z of the entire term. This is 0, this is 0, 3z square minus 3xy. This is f bar, only f bar. Now first consider div f bar. Div f bar means del dot f bar. Del dot f bar. So that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, the dot product with f bar. So f bar already the above vector. So I will write directly I bar dot I bar 1. So the first term dou by dou x of 3x square minus 3yz. F bar is this vector plus j bar dot j bar 1. So we will get dou by dou y of 3y square minus 3xz. This last term dou by dou z of 3z square minus 3xy. So making the differentiation partially, this is 6x and this is 6y, second term 0, and the last term the value is 6z. This is divergence of f bar. Similarly we can find curly f bar. Curly f bar means del cross f bar, cross product. So now curly f bar, second point. Curly f bar is equal to del cross f bar. That is determinant of the first row I bar, j bar, k bar. The second row dou by dou x, dou by dou y, dou by dou z, and in the last row I bar coefficient in f bar 3x square minus 3yz, second term j bar coefficient 3y square minus 3xz, and k bar coefficient 3z square minus 3xy. So now in expanding the determinant, this is I bar into dou by dou y of this entire term, dou by dou y of this entire term minus 3x minus dou by dou z of this term, that is minus 3x minus j bar into dou by dou x of this term, dou by dou x of this term, first term 0, second term minus 3y minus dou by dou z of this term, dou by dou z of this term, this is 0 minus 3y plus k bar into last term dou by dou x of this term minus 3x minus dou by dou y of this one, this is 0, this is minus, this is 3z, dou by dou x of 3z, this is also minus 3z. So this value I bar into minus 3x plus 3x minus j bar into minus 3y plus 3y plus k bar into minus 3z plus 3z. So this is I bar into 0 plus j bar into 0 plus k bar into 0. This is minus. So entire result is 0 bar. So curl f bar is equal to 0 bar. So div f bar, we got 6x plus 6y plus 6z, whereas curl f bar is equal to 0 bar. Next problem, seventh problem. Show that f bar is equal to x square minus yz I bar plus y square minus zx j bar plus z square minus xy into k bar is irrotational and find its scalar potential. So first you have to show that the vector is irrotational. So if f bar is irrotational, what is the condition? Curl f bar is equal to 0 bar. Curl f bar is equal to 0 bar, then f bar is said to be irrotational. Now consider curl f bar. Curl f bar means del cross f bar, that is determinant of. So what is the first row? I bar, j bar, k bar. Second row dou by dou x, dou by dou y, dou by dou z, and last row x square minus yz, y square minus zx, z square minus xy. So in expanding the determinant, I bar into dou by dou y of this term, dou by dou y of this term, z square 0, this is minus x only, minus dou by dou z of this term, this is minus x, minus j bar into dou by dou x of this term, dou by dou x of z square 0, dou by dou x of minus xy is minus y, minus dou by dou z of this term, dou by dou z of this term, this is minus, this is also minus y, plus k bar into last term, dou by dou z of, sorry, k bar into dou by dou x of this one, minus z, dou by dou y of this one, minus of minus z. So this is I bar into minus x plus x, minus j bar into minus y plus y, k bar into minus z plus z. So this is 0 I bar, 0 into j bar, 0 into k bar. So the entire value is 0 bar. So So since curl f bar 0 means what? Therefore curl f bar is irrotational. Curl f bar is irrotational vector. Now the scalar potential also. Scalar potential phi. So already I told that if f bar is an irrotational vector, then there exists a scalar potential phi such that f bar is equal to grad phi. And f bar is equal to grad phi ayatida, there exists a scalar potential phi. So now if f bar is irrotational, hence there exists a scalar potential phi such that f bar is equal to grad phi. That is, f bar is equal to x square minus yz into I bar plus y square minus zx into j bar plus z square minus xy into k bar is equal to grad phi. Grad phi is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So on equating like terms both sides, on equating I bar coefficient both sides, j bar coefficient both sides, k bar coefficient both sides, we get from the above we get what is dou phi by dou x? Dou phi by dou x is equal to x square minus yz dou phi by dou y, j bar coefficient. On the left hand side it is y square minus zx, and similarly dou phi by dou z is equal to z square minus xy. Our objective is to find the value of phi. So we have dou phi by dou x value, dou phi by dou y value, dou phi by dou z value as z square minus xy. Now I use the total derivative formula, but we know that from total derivative, by total derivative we have by total derivative d phi is equal to dou phi by dou x into dx plus dou phi by dou y into dy plus dou phi by dou z into dz. So we have dou phi by dou x. What is dou phi by dou x? X square minus yz into dx plus dou phi by dou y, that is y square minus zx into dy plus dou phi by dou z, z square minus xy into dz, that is equal to d phi. So now phi can be obtained by integrating both sides. On integrating both sides you get integral d phi is phi. So I am taking integration, I am integrating both sides. Integral d phi is equal to integral, so I am writing like term x square dx, x square coefficient dx plus y square dy plus z square dz minus of yz dx plus zx dy plus xy dx. So this is equal to integration x square dx is x cube by 3, y square dy y cube by 3 plus z square dz z cube by 3 minus integral of this entire term is d of xyz. The second term yz dx plus zx dy plus xy dz is xy dz is d of xyz. On the left hand side it is phi. Therefore phi is equal to x cube by 3 plus y cube by 3 plus z cube by 3 minus integral d of xyz is nothing but xyz, which is the required scalar potential.